So here we're gonna find all the integer solution of this equation. Since x belongs to z, x to the power of 5 also belongs to z. Hence, x to the power of 5 plus 2 is also an integer. Since the left side of this equation is an integer, the right side of the equation should also be an integer. 3 multiplied by 101 to the power of y should also belongs to z. Now we have three different possibilities for y. When y is negative and y is equals to 0 and y is positive. When y is negative, 3 multiplied by 101 to the power of y will be in the form 3 divided by 101 to the power of minus y, and this value is a fraction. Since we are getting a fraction for y is less than 0, it cannot be our solution. Hence y cannot be less than 0. Now we have y equals to 0. When y equals to 0, we have x to the power of 5 plus 2 equals to 3 multiplied by 101 to the power of 0, which is equals to 3. This gives x to the power of 5 equals to 3 minus 2, which is equals to 1, which you can write as 1 to the power of 5. This gives x equals to 1. Hence, one of our solutions is xy equals to 1 and 0. Now we will move to the third case, which is y is greater than 0. When y is greater than 0, we have the right side of the equation is always a multiple of 101. Since 101 is a prime number, the left side of the equation should also be a multiple of 101. Since x to the power of 5 plus 2 is a multiple of 101, when we divide x to the power of 5 plus 2 by 101, it will give a remainder of 0. Hence, x to the power of 5 plus 2 is congruent to 0 mod 101, which we can write as x to the power of 5 is congruent to minus 2 mod 101. Taking power 20 to both sides of this notation gives x to the power of 5 multiplied by 20 is 100 is congruent to minus 2 to the power of 20 is 2 to the power of 20, because 20 is an even number, mod 101. We can write 2 to the power of 20 equals to 2 to the power of 10 square, which is equals to 1024 square. This gives x to the power of 100 is congruent to 1024 square mod 101. When we divide 1024 by 101, it gives a remainder of 14. This gives x to the power of 100 is congruent to 14 square mod 101, and 14 square is 196. When we divide 196 by 101, it gives a remainder of 95. This gives x to the power of 100 is congruent to 95 mod 101. Since 101 is a prime number, according to Fermat's little theorem, a to the power of p minus 1 is congruent to 1 mod p, where p is a prime number. For the prime number 101, we have x to the power of 101 minus 1, which is 100, is congruent to 1 mod 101. But here we have got x to the power of 100 is congruent to 95 mod 101. Hence, this equation doesn't satisfy Fermat's little theorem when y is greater than 0. Hence, this condition doesn't give any integer solution, and we can neglect this condition. Hence, the only integer solution that we have is xy equals to 1 and 0. This is the only answer.